All right, this is 3.5, operations with matrices. Follow along with me on page 12 of your notes packets. All right, we'll be able to analyze data in matrices and perform algebraic operations with matrices. So, this concept of matrices, I'm not sure how much you've done with it before, but it should be pretty new to you. So what happens is matrices, so a matrix is 1, and then matrices, that's the plural. So we have one matrix, but we have many matrices. All right, and so it's just a way to organize data. All right, and the way that we organize that data is we put it in big brackets, and then we just kind of have some numbers that are like floating. All right, so say that I have a matrix like this in these big brackets. My 20 and my 13 are this is like 4 individual like numbers. They're not related to each other. They're not going to be added, subtracted, multiplied. This 20 and the 15, that's not division. It's nothing. It's just a way to organize data. All right, and so sometimes it's helpful to do this, and other times it's not helpful. So this first introduction is going to get us thinking about that idea. All right, so example 1, Coastal Sales Company has 3 locations in Florida. The manager at the Miami location would like to use a matrix to analyze its representatives. This matrix shows the average daily wages, and the annual sales. Remember, annual means once a year or yearly, so yearly sales made by each of the representatives that it employs. All right, and so here we see this matrix, and so we see these big brackets, and we see numbers in each one, and then each row means something. It's kind of like a table, all right? So part A is saying, let's add the numbers in each column, and let's interpret those results, all right? So let's add 900 plus 2400 plus 2700. That is a column. When we add those numbers, we get 6,000. And so that's our total wages, right? Because wages are the units for that column. So there were $6,000 paid or spent well, actually, the average daily wages add up to 6,000. So it's really like the sum of average daily wages. Okay, and then let's see, we add up the other column, add up the sales. When we do that, we get, I think, 660,000. So it tells us that 660,000 was earned in total sales. All right, so it's just to get us thinking about units and what's happening. Would adding the rows provide any meaningful data? So if we were to add 900 plus 145,000, if we were to add these, would it give us anything meaningful? So we would be adding average daily wage plus total sales for the year. It doesn't really make a lot of sense because what is that going to be useful for? Nothing. So we would say no. All right, part C, the manager wants to determine the average wages for all of the employees at the Miami location. He decides to divide the total of the first column, so this total that was 6,000, he divides it by 3, the number of different positions. What is the average? If we take 6,000 divided by 3, we get 2,000. Is this an accurate average? So is this 2,000, is it telling us anything? So it's telling us that the average of an entry, assistant, and associate daily wage is the average is 2,000. Is that telling us anything? Is it accurate? Not really, because we have the separation by position. Okay, so not really. Entry level, they make less than 2,000. So say it depends on your position, all right? Intro to matrices, and then so let's get into this concept. I don't want to take too long. This is going to be pretty straightforward. Big idea I want you to take away are that matrices have dimensions, rows by columns. All right, so this matrix, for example, we have 2 rows, 1, 2, and we have 3 columns. So the dimensions of this matrix would be a 2 by 3 matrix. So you would say 2 by 3 rows by columns. Oh, it's always rows by columns, rows by columns. All right, and so what we can do if matrices have the same dimensions, it's a key there, same dimensions, then we can add or subtract their corresponding elements. So if I want to take these 2 matrices and add them together, I would just take the top left number and add it to the other top left number, which would be -6. And I'm adding because that's what the question's telling me to do. So 0 plus 4, I would have a 4 up here. -1 plus 3, I would have a 2 down on the bottom left. And then 7 plus -3, I would have a 4 right here. And that would be my answer. My answer is going to be a matrix. What about this one? What if we try to add these two matrices together? Notice that matrix A is a 2 by 3 and matrix B is a 2 by 2. I cannot do this. I cannot add them together. They have different dimensions. So you would say not possible or no solution. We can also do something called scalar multiplication, which is kind of like distributing. All right, so a scalar is a number. It scales the values in the matrix up or down through multiplication. To multiply a matrix by a scalar, distribute the scalar to each matrix element. All right, so we're going to take -5 times matrix C. So we're going to take -5 and multiply it by every single number here. So our solution is going to be another 3 by 2 matrix. And we're going to take -5 times everything. So -5 times -5, I'll have 25 up in the top left. -5 times 1, I have -5 in that middle row. -15, and then we're just going to keep multiplying. 20, 0, and -30. All right, pause the video, give this a try. All right, hopefully you've come up with something. First thing you want to do is multiply matrix A by 4, which would give you 20, 12, 12, and -4. And then for this one, you have the option, you could either multiply by -3 and then add the matrices together, or you can multiply by 3 and subtract. That's what I'm going to do. It's up to you, personal preference. Just make sure that you're very careful. 3 times 1 is 3, 3 times 6 is 18, 3 times -3 is -9, and then 3 times 4 is 12. And then here, we have to make sure we remember to subtract. All right, 20 minus 3. Again, I'm using my corresponding elements. 20 minus 3 is 17. 12 minus 18 is -6. Careful here, very, very careful. 12 minus -9 really is 12 plus 9, which is 21. And then -4 minus 12 will give us -16. That's kind of a pitiful bracket right here. This should be a more firm corner bracket. All right, so that's all. Take a look at some practice and then let me know what questions you have.